Hello and welcome to STEM with Mr. N, where every week I perform different demonstrations and explain the science behind what we're seeing. This week's episode is supported by Snap Science from Collins Connect, and there's another one which ends in a tasty treat as I explore the science of honeycomb. Let's check it out. Snap Science is a great online resource from Collins Connect which contains a host of progressive science planners, and it can be used by schools to develop their own science curriculum. I'm going to talk a bit more about Snap Science later in the video, as well as tell you how you can access some great free resources, but for now let's explore our science of honeycomb. Honeycomb toffee is a treat which is enjoyed all around the world, and it goes by different names in different places. In Britain, you'll usually hear it called honeycomb or cinder toffee. In New Zealand, it's hokey pokey. And in Scotland, you'll quite often hear it being called puff candy. But what is it that makes this candy puff up and be full of holes? Well, I decided to make my own at home and share the recipe with you because it's a really simple recipe and it is quick to make. So it's a good one for you to try at home, provided you have an adult with you, because it does involve using the cooker. Once my puff candy is made, I'm then going to explain the science behind what is happening in this sweet treat. To start with, I'm going to line a baking tray with tin foil, and then I'm going to put a teaspoon of oil into the middle of it and spread it around with the spoon so that the tin foil has a good covering of vegetable oil. This is to stop the candy from sticking to the tin foil later. And now I'm going to turn my attention to the stove. I'm going to turn the stove on to a low heat underneath a large pot. Into this pot, I'm going to put 100 grams of caster sugar and then 2 tablespoons of golden syrup. I'm going to use a wooden spoon to mix this around in the pot. Right now it's quite a sticky, lumpy mixture, but as this pot stays on the heat, the sugar is going to dissolve and we're going to end up with a nice golden liquid in this pot. Stir the pot occasionally or swirl the ingredients round, but it doesn't need to be stirred constantly. After about 10 to 15 minutes, this mixture should be ready. You'll know your liquid is ready for the next stage because when you drag the wooden spoon across the bottom of the pot, it will not feel gritty. You want to have a nice smooth liquid in your pot. Once the liquid is ready, take the pot off the heat and put in a heaped teaspoon of bicarbonate of soda, and you'll see that the liquid is now starting to froth up. It's got a white foamy look to it. Quickly mix the bicarbonate of soda into this mixture and then pour it into your lined baking tin and then just leave it to cool. Once you've poured the mixture into your baking tin, immediately put the pot in some water to soak because you don't want the toffee getting all stuck to the inside of your pot. Now all that's left to do is to leave the puff candy to cool and harden. Once that is done, I'm going to take mine out of the baking tray onto a plate so I can explore how well I've made it. And then I'm going to explain the science behind what makes this candy puff up and be full of holes. But for now, I'm going to explain a bit more about Snap Science. When you subscribe to Snap Science, you'll be issued with login details. When you log in, you get to see this overview screen, which has Teach, Assessment and Class Materials. When you click on Teach, you are then asked to select which year group you are teaching. I've clicked on Year 3 for this example, and you see that I've got all of the module titles that are uploaded for Year 3. When you select a module, you see that you now have all of these different lessons available to you, which usually have an interesting sentence or question which have to be used as a lesson starter to get the pupils thinking about what you are going to learn. When you select a lesson, you get to see this lessons page where you have a lesson plan and various resources that go along with it. Sometimes these are paper resources for the teacher or for the pupils, sometimes it's slideshows, sometimes it's videos. This honeycomb experiment was taken directly from Snap Science, and it was very easy to gather together the required materials and to follow the instructions. Right now, Collins Connect are also providing some free resources relating to coronavirus. I've put a link in the description to where you can access these great resources to help teach your children about what is going on right now with the global pandemic. And now it's time to check in on my honeycomb, which is cooled, hardened, and I've taken it out of the baking tray. The first thing I'm going to do is snap it open so that we can get a look at the inside. You'll see that my honeycomb has puffed up and it does have the holes inside it that we would expect to see from honeycomb that we're buying in the shops. But what is it that causes these holes to form inside the candy? Well, when you are cooking the sugar and golden syrup in the pot, this mixture reaches a very high temperature. When you add the bicarbonate of soda, an endothermic reaction takes place. That is a chemical reaction that uses heat. The bicarbonate of soda undergoes what's called a thermal decomposition reaction, which means that the bicarbonate of soda breaks down because of the heat in the mixture. When bicarbonate of soda breaks down, it releases carbon dioxide gas. Because this is being released into a thick mixture, it creates all of these bubbles in the mixture. And as the mixture cools and hardens, these bubbles are retained inside the candy. So that is what gives honeycomb candy all of these holes inside it and actually makes it look like a honeycomb from a beehive. My honeycomb candy's turned out alright. It is still a bit soft right now at the point where I've broken it open, so I should maybe leave it to harden for a wee bit longer before I decide to eat it and test it against some store-bought. Well, that's all for this week. I hope you've enjoyed it. A special thanks to Collins Connect for supporting this video and giving me access to Snap Science. And another special thanks to Mason & Sons of Scotland for gifting me this wooden STEM with Mr. N sign. As always, I would like to take this opportunity to answer any science questions you have about any science topics at all. So feel free to email me at stemwithmrn@outlook.com and I'll get back to you with answers to your questions. Over the past few weeks, it's been great seeing some of the work that pupils are producing inspired by these videos. So feel free to send on examples of work to that email address, or you can message the STEM with Mr. N Facebook page, and I've put a link in the description to that. You can subscribe to the channel by pushing the button here, and I've added links here to the other STEM demonstrations I've done so far. This has been STEM with Mr. N, exploring the science of honeycomb.